reviewing. Okay, folks. Would you rather work on the non-calculator?
Yeah.
Okay. All right. So I think 162 degrees is kind of mean to put on a non-calculator portion. So if I'm trying to convert that to radians, what should we be multiplying by?
180 over
Not 180 over pi. Pi over 180, right. Because we have to reduce that. So we can reduce that by, what, 58 over 90? Which can be reduced, right? Did I do that right? No, I didn't do that right. Come on, 81. What am I thinking?
I don't know. What are you thinking?
Right, just dividing by 2, and then we can do it again, right? Or what else can we get rid of? 9, thank you very much. Right, so 9 pi over 10. Okay. And if you didn't want to do 9, you could do 3, and you could do it twice. Sure. Good. I did wonder where that disappeared to. Oh, creepy. All right. Not asking. Okay, so 180 over pi, what's going to cancel out? The pi's. So effectively, you could have substituted pi with a 180. 11 times 180 over 8. Since we are not using a machine to do this, we're probably going to have to reduce first. Okay. We'll be happy to have you again next year. All right, now. Possibly in multiple math classes. All right, now. What goes into both of those? 8 does. Okay. If you don't know whether 8 goes into 180 or decide, yeah, go with something smaller than that. Like, okay. Anything go into 90 and 4? 2 does. So we really have 11 times 45 over 2. Once again, cruel for a non-calculator. Oh my goodness! I cannot believe that just came out. But yes, we'll be happy to have you again next year. But this particular, yes, you do have a non-calculator portion. I should check on that one. Yeah. This is definitely not something I would want, you know. What do you got? 450 plus another 45 is 495 over 2, right? So we...
See, I could never...
You couldn't do 45 times 11? 450 plus 45? Yes, that's fine. That's fine. You can do it on paper. 495, and then you divide that by 2. Ooh, that'll take us back. Let's see. 2 goes into 4 twice. 2 goes into 9 4 times with 1 left over. 2 goes into... Yes, I also did not teach you how to tie your shoe, but you should be able to do that at this point of your life. 2 goes into 15 7 times with 1 left over, so 247.5 degrees. Yeah, we won't be that cruel. That's a little bit beyond.
Wait, is there an answer to this?
Question 3, find the exact values of the trig functions. Okay, find tangent of A. What's the tangent of A? Opposite over adjacent. 20 over 48. Guaranteed it won't look like that on the test. What will it look like? Yeah? It's multiple choice. 20 over 48 is not going to be listed. 5 over 12 will be listed. That's true. Okay? Yep, take out the 4. All right? How about the cotangent of A? Woo, 12 over 5. Look at you with your whole reciprocal function self. That's nice. Yeah, that's right. For the viewers at home, you know, the other non-Staleyite people, Choshakao. Well, right, because there's going to be other trig kids watching this video, since I'm practically the only one that records anything. Anyway, so we got SOHCAHTOA.
Yeah, what if they were watching?
You think they're going to watch my video? Okay, that's funny.
Maybe.
How do I feel about that? Kind of depressed. Thank you. Okay, so you've got your reciprocal trig functions that go with the sine, cosine, and tangent. For cosecant, secant, and cotangent. Okay, theta is an acute angle in a right triangle satisfying the given condition. Evaluate the indicated trig function. Okay, cosine theta. I say we draw a triangle. We got theta. Which side is 3 and which side is 4? 3 is your adjacent side, yes. 4 is the hypotenuse. Therefore, what is...
5.
It is not 5. I know, because the 3 and the 4 show up. That's only true if the 3 and the 4 are both the legs. Then 5 would be the hypotenuse. It is the square root of 16, take away 9, or the square root of 7, using our Pythagorean theorem. Thank you very much. Okay, how about the secant? Ooh, did I waste my time? Oh, man. Well, it was a nice trip down memory lane to think about the Pythagorean theorem. Plus, there are going to be many questions, or at least a few questions on the final, where you have to draw the triangle, and based upon the trig function given to you, you have to know which sides to label.
So the final isn't multiple choice?
Yes, the final is multiple choice. It always is, and always has been, and always will be.
Why did you say
Okay, so secant, if I've got the cosine, the reason I wasted my time is secant is 4/3. Okay, I just had to flip it over. Okay? Now, that's not going to be necessarily that easy for question 5. All right, I will have to draw a triangle for this one. Okay? So cosecant, that'd be Cho, right?
Wait, what?
Easy.
Oh, wow.
What? Cosecant goes with hypotenuse over opposite, so which one is the 15? The hypotenuse. All right, that'd be theta down here in the corner. Which one's the opposite? The right side. So, what do you got for the remaining side?
Okay, why'd you just go with
Cosecant goes with sine, so if you wanted to, you could write sine theta equals 2 over 15, if that would be more helpful to you, and then you could do opposite over hypotenuse.
Oh, never mind.
You're the one that wanted me to do sine. Okay. Now, you need to tell me what the bottom edge is. We got 225, that's 15 squared, minus 4, which is the square root of 221, which is not a nice number. Right? So cosine, what's the cosine of theta? Radical 221 over 15, right? Adjacent over hypotenuse. So obviously in the first one we didn't have to draw a triangle because we just had to use the idea of the reciprocal trig function. Second one we did have to draw a triangle. Okay? Solve secant theta equals radical 2 for theta. Okay, and you're only allowed to give me an answer between 0 and 90.
I'm going to guess 45.
60.
Well, secant goes with which trig function? That's cosine. And that would be, if I flip this over, I get 1 over radical 2. If I rationalize that, I'd get radical 2 over 2. And I believe you are correct with your 45-degree assumption, because that is the only place between 0 and 90 where the x value is radical 2 over 2. Nice job. Yeah, that kind of gave it away, didn't it, man? Didn't even make it hard. Okay, so how about the next one? Between 0 and pi over 2. Don't you dare quote me a degree measure. Look, why don't we just pay attention to the circle? Sine, is that an x value, a y value, or a slope?
That would be a y value.
Y value, and it's the one closest to the top edge of the circle?
Yep.
All right, so it has to be, Pi over 3. Nice.
Oh my, good job.
Right? Right? Yes, we know you can read. Evaluate without using a calculator by using ratios in a reference triangle. Cosine 210. Why would I need to do that? Why don't I just look at the circle and tell you what the cosine of 210 is? I mean, cosine of 210 is this one right here. It's an x value, right?
Yep.
We got an x value, and we're out towards the edge of the circle on the negative side. That is negative radical 3 over 2, folks. Remember how they go in order for those viewing at home. What's the one that's halfway in the middle? Halfway in the middle. What's that measurement? Negative half. What's the next one after that? Negative radical 2 over 2. We already just established that this one was my negative radical 3 over 2. And then what's the very last one on the outside edge? Negative 1, right? Those are your x values. They go in order. Yes? Oh, somebody falling asleep? Okay. Keep in mind, if when people start saying things about memorizing, that all we're doing is taking the numbers 1, 2, 3, and 4, taking the square root, and dividing by 2. Some of them reduce, some of them do not. But they stay in order. How about the secant of 3 pi over 4? Secant goes with which trig function? Cosine. So we need the cosine of 3 pi over 4. Cosine is 3 pi over 4 is in the middle of quadrant 2. What's the cosine of that? Is it radical 2 over 2?
Oh, it's radical 2.
Okay, wait a sec. The cosine. I want the cosine first.
Negative.
And it's negative? Okay, so now answer this question. Now you can write negative 2 over radical 2. That will not be an answer choice. But if you rationalize it, what do you get?
Negative radical 2.
So just do the reducing.
Yeah.
Yes, we are definitely reducing, reusing, and recycling.
Oh, wait.
Okay?
Oh, so you just have cosine.
I found the cosine and flipped it over. That's all. If I want the secant, it's the reciprocal of cosine. So find the cosine. That'll help you. All right. Ooh. Let's see. Negative square root 2. Okay, where's negative 5 pi over 4?
It's the middle of the second quadrant.
Middle of the second quadrant. Let's see if we agree. 1, 2, 3, 4. Yes! We should know the answer to this because we were just there on the last question. Negative radical 2 over 2. Remember, it's an x value?
We're on fire.
Yes. Okay.
Rain outside.
It's a class final.
Is it really a compound?
Find the value of the unique real number theta between 0 and 2 pi. So my answer better be in radians that satisfies the given conditions. Well, it's going to be hard to screw up the whole radians degree thing because all your answer choices will be radians. Okay? Boy, that'd be an interesting trick. See how many kids would pick the degree one when it said between 0 and 2 pi? Nah, that's pretty evil. Okay. So cosine theta equals negative radical 2 over 2. They tell me, so that's a negative x value. Which two quadrants does that put me in? Negative x value. Puts me in 2 and 3. And tangent is positive. Which quadrant does that narrow me down to? Down here in quadrant 3. All right. So now we know which quadrant we're in. We're down in quadrant 3. And they want the x value to be negative radical 2 over 2. Well, it's not negative 1/2. It'd be negative radical 2 over 2. which is this one right here, and 5 pi over 4, nicely done.
He just looked at the answer.
No, that would be you. All right, now. Yes? Ask the question.
No, it's a good question. How do you know it's positive on there?
Because it says right here.
No, never mind. I figured it out.
Okay, so your slopes are all positive in quadrants 1 and 3, right?
Yeah.
Everything that's got this kind of up to the right motion has got a positive slope.
So when you found the positive, you just
That's not important right now.
Yes, so once I narrowed down my quadrant, then I found my x value, and I followed it down and then identified the correct angle measurement.
So how's it?
How what?
You said so.
I don't have to find the slope. They didn't ask for the slope. They asked for the angle that made this true. What angle down there in quadrant 3? So they narrowed down which quadrant I was in by giving me a negative x value and a positive slope. They just told me the slope was positive, but they're not asking for the slope. They're asking for the angle in that quadrant that would make this true. Okay, now question 12. They give me the slope at 1. All right? Have I drawn a blue line on that red unit circle that has a slope of 1? I think I did. Okay. Now, it says this, that the sine is at an x value, a y value, or a slope. That's a y value. Is negative. Where are we located? If the slope is 1 and the y value is negative. Man, we're in quadrant 3 again. All right. So, what angle measurement? Boy, this is a really dumb question. All right, what angle measurement should we be at? Oh, it's the exact same answer as the last one. I don't know, man. We should.
Who made this?
We chose the problems from a test bank, and it selected the values to plug in. So it was.
Do you make the final?
Yes, we
Do you
do.
like choose the wrong answer? Or do you just put random things?
Yeah, like one of them.
How many questions can we get in a row? Okay, find the specified quantity. Yeah, but I didn't even get the answer out. Find the period of y equals. I suggest you put it into fireproof form. Yes, you can. Yes, you can. Stop complaining, even you people at home. Okay, y minus k over b equals the sine of x minus h all over a. I'm really running out of room. Okay. All right, so what is y divided by? 3. Okay, so that wasn't too hard. We need to think about what's going on in these parentheses. Remember how we would take that thing and divide by 1, and I would say things to you like, what would you multiply the top and bottom of that fraction by? So we could turn this into a 1x, thank you very much, it's a 4. Okay, so if I multiply this by 4 over 4, that's going to give me x minus something over 4. What is that something? Okay, so we're struggling with pi over 2 times 4 over 1. 2 pi, thank you very much. Just like the Greek rapper that supposedly died. All right, now. 2 pi, yes.
How do you spell it?
He was Greek. How do you spell his name? 2 and a pi?
2 pi.
Okay. Okay, find the period. Find the period. Period is, what's the original period of a sine wave? 2 pi times, and then we, in order to figure out what the new one is, we have to multiply times the horizontal stretch or shrink. What is the horizontal stretch or shrink? It is 4, right? Your A value is 4 in this case. So what is the period? 8 pi. We definitely stretched it. Okay? It's a mean? A meme about 5 pi over 4? Okay, great. I like the creativity. Write an equation for a sine curve that has the given amplitude and period in which passes through the given point. Okay? So, it's... Folks, what's so significant about this point? They gave you me h and k. Okay? What does this value represent? That is my b value, right? Now, to get my period, or to get my value of a, we remember that the original period, 2 pi times whatever a is, in this case is equal to pi over 2, because they gave me the period. Can you solve that for a? It is 1/4, right? You divide both sides by 2 pi, which in middle school would be the same as multiplying by the reciprocal, and so we do get 1/4. Right? Okay? Write an equation. So how about, what do you think we should write? Y over 5, good, good, equals sine x over 1/4. What if the answer didn't look like that? What if it's multiple choice, so we have to find an answer that looks like this one, or is equivalent to? Okay, so I like that idea. Multiply by 5, so we got y equals 5 sine. A lot of times you won't see x divided by 1/4. We could do 4x. Yes, if you multiply the top and the bottom of that by 4, you get it to look like this. That is a more likely multiple choice answer for that question. You would do, this is what we were doing in our heads. We were multiplying the top and the bottom of that by 4. Okay. Does that make more sense? Okay. Graph the function. Y equals, okay, so what's the 5 doing to the tangent function? What does the 5 do to the tangent function? Riddle? No, you should know what the 5 does. It makes it taller. It's a vertical stretch, isn't it? Okay, so we probably should zoom in because we don't have a lot of room here. Now, I hate this question. Why? Because I promised you when we were doing this in class that we wouldn't do a vertical stretch on tangent because it is really hard to see unless you're going to use individual points. So we did things like shifting it left, right, up, down, and we definitely did horizontal scale changes, but we did not do the vertical ones. Okay? Because I don't like you. Okay, so if you have done a vertical stretch only, then you have not changed the original asymptotes of tangent. What are the original asymptotes of tangent? Pi is definitely not one of them, folks. Think about the unit circle. Where on the unit circle do you have undefined slopes? Pi over 2 would be one of them, yes. Negative what? Negative pi over 2 is the other one. What's the distance between those asymptotes? Pi. Remember, the period of the tangent is only 1 pi. Okay? So this is the part that's really bad, is just having to stretch this thing. It's going to look pretty much the same. It's just been stretched 5 times. So that's, that's not a good choice on graph. And yes, this would continue on over here. What would this next asymptote be? 3 pi over 2. Okay? Cheating. 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 I don't think so. All right. So it would continue on for a long time. Yep. Yep. Therefore, you're healthy. Okay. Okay, so cosecant goes with what? Goes with my sine, right? It's the reciprocal of the sine function. Okay? Can you name any of the x-intercepts of a sine function? Any place where the sine function crosses the x-axis. Pi, yeah, that'd be one. 2 pi, that'd be another one. Oh, yeah, right at 0, 0, the origin. Okay, how about negative pi? Okay, these are all the x-intercepts of a sine function. So when we change it to cosecant, what happens at those magical locations? Asymptotes, thank you very much. Right? The x-intercepts of a sine function are the asymptotes of a cosecant. Yes, really. Okay, now, what was the highest value on a sine wave? 1. And what's the lowest value on a sine wave? Negative 1. Okay, so now what's so special about those maximums and minimums of the sine wave? That's where we have these little things coming down and touching that point and going back, remember? So, have all these places where it stays in the boundaries of the asymptotes. So wherever the sine maxed out or was minimized, then you can use those points.
Why are like the x-intercepts asymptotes?
Well, if you think about it, if you plug a 0 into this fraction, what is 1 divided by 0? It's undefined. So so the 0 on the sine wave. And folks, if I ask you for the secant function, the zeros on the cosine create the x-intercepts on the secant. Likewise for the cotangent graph with the tangent. Find the exact value of the real number y. Okay? Some of you need to remember the range of the inverse cosine function. Remember, it was the top half, right? Do I have a way to remember this? Well, the other thing that you guys, most of you have forgotten, is the picture for the cosine inverse function. The cosine inverse function looks like this. It goes from -1 to 1 and 0 to pi. If you knew the picture, that would help. So whether you're thinking in terms of the circle or you're thinking in terms of the actual graph of the cosine inverse function. Now, what are they asking me for here? What is this thing that they gave me? And because I run across you guys all the time saying, I get answers like radical 3/2. Which makes me think, okay, now this kid doesn't understand what he's been given and what he's being asked to give out from this particular function. So what is this thing right here, negative radical 2/2? Your choices are x value, y value, slope, or angle measurement. That's an x value. What are you being asked with the arc cosine or cosine inverse? What are you being asked to give? You can even see it from the graph of the cosine inverse function right there. What's on the y-axis there? An angle measurement. Thank you. We need an angle measurement. We have been given negative radical 2/2. Somewhere over here. And we want the angle measurement. So, if you like to think about it on the circle, we could think about it in the circle. See, like there's -1/2, there's negative radical 2/2. So it's there on a circle. 3 pi over 4. Sine inverse. You guys also have forgotten about that. Sine inverse would be on the circle would be on the left or on the right half of the circle. It goes from -pi/2 to pi/2. Now, I know lots of you like to quote things that are in quadrant 4 in terms of things like 5 pi over 3. You can't use things like 5 pi over 3. Maybe it would help you if you understood what the graph of the sine inverse function looked like, which we talked about a long time ago. It goes from -1 to 1, and from negative pi over 2 to positive pi over 2. Things like 5 pi over 3 don't even exist on that graph. Not in that world. It's because the domain was restricted so that we would have a function, so that it would pass the vertical line test. All right? What is this thing, radical 2 over 2, that they gave me? Your choices are x value, y value, slope, or angle measurement. That's a y value. What are they asking me for? An x value, a y value, a slope, or an angle measurement? They're asking me for an angle measurement. So, find positive radical 2 over 2. Now, you could do that on the circle, or you could find positive radical 2 over 2 here. What is it? Pi over 4. Okay, you're going to have to draw a triangle. The given information is right here in the very first part. So, draw a right triangle and label the sides, please. How dare you speak ill of the king? Okay. All right, so which side was 1 and which side was 4? If you got theta down here. 1 was the opposite, okay. 4 was the hypotenuse, which made what for the lower side? Radical 15, right? Radical 16 minus 1 is radical 15. Okay, now we want the cosine of that. Yep, we want the adjacent divided by the hypotenuse. Okay, now question 20 requires you to think about the unit circle. So, what is the sine of pi over 6? The sine of, it is 1/2, that's true. So this question is really the same thing as arc cosine of 1/2. Now, if you remember your arc cosine, you're only allowed to give me an answer in the top half from 0 to pi. It has to, is this an x value, a y value, a slope, or an angle measurement? That's an x value. So if the x value is 1/2, pi over 3, ding, 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 nicely done. We were given the x value 1/2, and we followed it. We followed it to the top half of the circle to pi over 3. What's the question? Come on, I can see the wheels turning. Yeah. Okay, do you understand where we got the 1/2 from? So they started me out over here at pi over 6, whoops, and they asked me for the y value, so that's where we got the 1/2 from. But then, if you do the substitution, you realize that this part in here is now an x value. So they're using it, so they started out with pi over 6 and said, what's the y value? Got that. Now they're saying, what angle measurement inside the arc cosines or the cosine inverses range has that same x value? It's kind of weird because they're switching from using it as a y value to using it as an x value. That's why you have to pay attention on this question. Okay. Use the fundamental identities to find the value of the trig function. Find sine of theta if tangent theta is negative 5/12. Okay. We do need to draw a picture, but I need to really be careful. So the tangent is negative, so we're either in quadrant 2 or 4. And then it says that the cosine is positive. What does that mean? Is that an x value, a y value, or a slope? That's an x value, right? So we know that we're in which quadrant? 4. So when you draw your triangle, so we've got 5 over and 12 down. We want to find the sine. Did I do? Yep. Or did I do that wrong? Did I do that wrong? Come on, folks. Tangent.
Oh, yeah.
I did it wrong, didn't I?
Oh, and I didn't.
I'll just label the sides differently. Okay, the opposite side and the adjacent side. So that was my fault.
Is the theta always like closest to the...
Closest, yes, closest side of the x-axis. Always closest side of the x-axis for the reference angle. The sine is not just -5. I know you want to say it's a y. It's the y value, but I need you to think about this. It's not a unit circle. You need to find the radius or the length of the hypotenuse. So, how do we do that?
I think it's radical 160.
Yeah, 12 squared plus 5 squared. All right. So, did we get 13? Yes. So, the hypotenuse is 13. So, they want me to find the sine of theta. Opposite over hypotenuse. Well, it does have to be negative because the y value is negative in that quadrant. Find the tangent of theta if the secant. Okay, so secant is positive. That means cosine's positive, right? So cosine is positive in 1 and 4. And then it says that the sine is negative. So which quadrant are we in? We're down here in quadrant 4. Once again. Man, talk about redundant. All right. So if maybe we should think in terms of cosine. What's the cosine of theta just for 6 over radical 37? I mean, you guys might function a little bit better if we do that. So so what's the top edge here? 6, right? It's the adjacent side. Remember, it's adjacent over hypotenuse. Okay, and so the hypotenuse would be radical 37. All right, now help me find the other side. Okay, so let's see here. Probably going to have to do that up here because I'm running out of room. So we got radical 37 squared equals the square root. Oh, I should do that differently. Sorry. Radical 37 that's the square root of 6 squared plus x squared. So it does have to be 1. Is that right? I don't know. I'm like losing my mind here. 6 squared plus x squared equals radical 37 squared, which is 37. So, no, it's not 3, 2, 1. Okay? So, what value do we get over here? When you say radical 1, which is, it can't be radical 31. Isn't it just 1? Now, I need to know if it's positive or negative before you leave.
It's negative.
Thank you. And so my tangent of theta will be -1 over 6, opposite over adjacent. Yes.